All right, grab yourself some popcorn, grab yourself a drink, buckle up. This is a long one and an important one. Factoring polynomials. So we have three learning goals. We are going to learn about the remainder theorem. We're going to make connections between the remainder theorem and the factor theorem to help us factor polynomials. We're going to start out though with a quick little review of the last lesson. Divide, and if I see x minus a, right, this is like x minus a, that means you can use synthetic. If long division is your preference, you can use long division, but I'm going to just review synthetic. So your a value, which is 2, then our synthetic division, our coefficients, 1, 4, 4, negative 6. Don't forget to always double check descending order of x, and if you're missing any x terms in both the divisor or the dividend, then you need to make sure you have a 0 placeholder. Bring down the 1, multiply, 2 times 1 is 2, we are always adding. 6, 2 times 6 is 12, we're always adding. 16, 2 times 16, 32, we're always adding 26. Now how does that give us an answer or an expression? 26 is our remainder, 16, 6x, x squared. And of course our division statement, therefore x cubed plus 4x squared plus 4x minus 6 equals x minus 2 times x squared plus 6x plus 16 plus our remainder. 1b, we're going to find f of 2. And if you notice something, that function f of x is the exact same function from 1a. So let's see what happens when we find f of 2. Put a 2 in for all the x's. I'm not going to go through all the steps. You can just use your calculator. That's just straight up calculator work. And hopefully, after you use your calculator, you should get 26. Look back at our answer to 1a and see if you notice anything about 1a and 1b. Keep staring. Look back and forth, back and forth, back and forth. Hopefully, you're noticing that from 1a, I divided by x minus 2, and I got 26 as my remainder. For this question, I found f of 2, and I got it to be 26. If we make connections here, those two things are the same thing. That's your a value. And putting that into my equation straight up without doing any dividing gave me the remainder. That leads us to the remainder theorem. The remainder theorem states what we just drew the conclusion to. When a polynomial is divided by x minus a, the remainder is equal to f of a. pretty straightforward. Let's practice that. Example 2, find each remainder. So for a, your a value is -7, right? Don't forget it's like x minus, so if it's a +7, that means a is really negative because two negatives make a positive. Or you can simplify that thought process to just x plus 7, what's the opposite? -7. So f of -7 equals, replace all the x's with -7s. Calculator work, hopefully you get -19. So that tells us that our remainder is -19. B, 2x plus 1, that's a weird one. It's kind of like x minus a. It's like an ax minus b type scenario. Really just want to know what makes that 0, which would be -1/2. So we'll maybe make that little note here, a equals -1/2. Or if you're a fraction hater, -0.5. I'm assuming most of you at home are preferring decimals, so I'll do -0.5. Replace all your x's with -0.5. And when you do that, hopefully you get 0. 0 remainder. What does that mean? If there's no remainder left, that means that it's a perfect factor. It divides evenly. Anything that gives you 0 remainder divides evenly. So there's an extension of the remainder theorem, which is the factor theorem. So a special case of the remainder theorem states that x minus a is a factor of f of x if and only if f of a equals 0. In other words, the remainder is 0. This is the important thing to remember to highlight. It's going to help us factor. Up until this point in your math career, it has only been possible to factor polynomials of degree 2 without common factoring first. So I could have thrown a cubic or a quartic at you in the past, but there would have had to have been some common factoring to get it down to at least a quadratic. This is a trial and error process, but as a general rule, you can only use numbers that are factors of the last term divided by factors of the leading coefficient. So that's something else you're going to want to highlight, make note of. Now, if your leading coefficient is just 1, then really it just boils down to factors of the last term. Example 3. We are going to factor, and we're going to do this the long way. Well, somewhat long, I guess we could say. It is a way, it's a legit way. The bigger I make the number on the back end, that constant term, the longer this is going to take. So from the previous slide, we want to test factors of the last term divided by the leading coefficient. The leading coefficient is just 1, so that means it boils down to factors of this. So here's the trial and error part. You are going to try factors of -6, which you could try plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. So I'm going to get you to try that, and as I'm trying it, I'm going to write all of these factors down. So f of 1, f of -1. f of 2, f of negative 2, f of 3, f of negative 3, f of 6, f of negative 6. So this is exactly the work that you would show, and you would just plug those numbers into the function using your calculator and you come up with some numbers. So I'm just going to give you what they are. Negative 12, 0, negative 12, 0, 0, negative 12, 168, and negative 180. And that's just using your calculator. Factor theorem states that only if you get a remainder of 0 is it a factor. So this, not a factor. Got 0, that's a factor. Nope, yes, yes, no, no, and no. What if you got 4 zeros? Before we give the final answer, just think about something. What if you got 4 zeros? That's a built-in self-check that you did something wrong because the degree of this function is 3, right? That's the highest exponent, which tells you at most it has n distinct zeros or factors. In this case, the maximum you could possibly have is 3. So just a quick built-in self-check. So to actually finish off the answer, like it asked us to factor, so therefore, in factored form, f of x equals, now if f of negative 1 gave us 0 in factored form, right, x plus 1. Negative 2, x plus 2, 3, x minus 3. You have successfully factored. Oops. Yay. So we successfully factored something that was a larger degree than 2. So again, this is, depending on your point of view, this could be considered a long way. It wasn't that bad. You only had to test 2, 4, 6, 8 numbers. If you do it this way on a test, I need to see that you tried every single number, every single factor. So even if you stopped at 3, I need to see all the work that you did for all of the other numbers to make sure they don't actually work. And that was just for 6. If I give you a number like 48, there are so many more factors that go into that, you could be sitting there for a long, long time. It's legit. I wouldn't recommend it. I'm warning you if you do it that way, I need to see all of this work. So I don't have to see you sub in the numbers, but I need to see exactly how I have it laid out here with what the actual number equaled. So if Mr. Sulio is saying, trying to get us not to do it this way, how could we do it? Good question. So we're going to factor. F of x equals x cubed plus x squared minus 34x plus 56. My leading coefficient is 1, so this just boils down to factors of 56. So over here, I'm just going to write try. So try like plus or minus 1, plus or minus 2. Usually once you go there, does 3 go into 56? No. Does 4 go into 56? Yes. And usually once you've tried the first few, you should come up with an answer first. So try those. You should get 2 to work. So here's what you want to write. F of 2 equals 0. If you put 2 into that function, you can prove it to yourself. You get 0. Therefore, x minus 2 is a factor. Once you're there, you could do synthetic division. So we already know that this factors evenly into our function f of x. This is your a value. So you could do synthetic with 2, then write your coefficients, 1, 1, negative 34, and 56. Bring that down, 1 times 2, 2. We're adding, 2 times 3 is 6. We're adding 2 times negative 28, negative 56, we get 0. That is your built-in self-check that your factor theorem worked, or that you know how to synthetic divide properly. If you don't get 0 remainder, that means you messed up somewhere. So we have 0 remainder. That means this is negative 28, 3x, and x squared. Now you just have to factor that, which that's just a simple trinomial. Hopefully you remember from grade 10 and 11 how to factor that. Two numbers that multiply to negative 28, add to 3. Hopefully you're thinking x plus 7, x minus 4. We have now successfully factored it all the way. Therefore, f of x equals our first one, x minus 2, and then x plus 7, x minus 4. If you're wondering if the order of those matters, it does not matter what order you multiply in. So as long as you have those three factors in some order, you're A-okay. So that is my preferred method, as opposed to trying all of the factors of 56 and showing me all of the calculations you did. C. We're going to try it again. So you want to try factors of 24 because my leading coefficient is 1. So we want to try, and you don't have to write this tripart, I'm just doing it so you guys know. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4. Again, you should get, within the first 3 or 4 you try, you should almost always these work. I know for a fact 3 works. So it doesn't matter what, there's other ones that work. It doesn't matter which one you do first. You'll still get the same answer at the end of the day. So f of 3 equals 0. Therefore, x minus 3 is a factor. That's your a value. You can synthetic divide, assuming you like that. Coefficients. Bring down the 1. 3 times 1, 3. We're always adding. Multiply. Adding. Multiply. Adding. 0 remainder. We did our work correctly. This equals x squared minus 2x minus 8. That's a simple trinomial, two-factor. X minus 4 and x plus 2. Therefore, f of x equals, I'll change up the order just to change it up. X minus 4, x plus 2, and x minus 3. Hopefully that's not too bad. We're finding it okay. Example 4. We're going to move on to a challenge question. So this is like a thinking or application question. This is a question I like. When 2x cubed minus mx squared plus nx minus 2 is divided by x plus 1, the remainder is negative 12. X minus 2 is a factor. Determine the values of m and n. This is a good question. Let's start out with the first sentence. So when that's divided by x plus 1, the remainder is negative 12. Well, the remainder theorem tells me if I do f of a, it should equal negative 12. So in this case, what's your a value? If it's x plus 1, that means your a value is negative 1. So I know when I put -1 in for all those x's, it's going to equal 12. So 2, -1 cubed minus m times -1 squared, n times -1 minus 2. That whole thing equals 12. Do some math. -1 cubed is a -1 times 2 is -2. -1 squared is +1, so that's -m minus n minus 2 equals 12. Bring over those two -2's, become +2's. And we should get -m minus n equals, oh, looks like I forgot the negative from the 12. -12, -12. Bring over those positive, or those -2's become positive. This should be equal to -8. So there's 1/2 of the question done. That's from the first sentence. Let's try the second sentence. It tells you x minus 2 is a factor. That is an implicit way of telling you that when you sub in f of 2, you get 0. So over to the array here, we're going to put 2 in for all of our x's. And we know that since it's a factor, it should be equal to 0. Go through the math. 2 cubed times 2, 8 times 2, 16, minus 4m plus 2n minus 2 equals 0. Bring over that 16, so 16 minus 2 is 14. Bring that over, becomes -14. So -4m plus 2n equals -14. We have two equations, two unknowns. So you could solve this just like you did in grade 10 using substitution or elimination. You could graph those, but I'm not even going to bother doing that. Graphing, no one ever finds a point of intersection by graphing, unless they're forced to. I'm going to use substitution. So what I'm going to do is I'm going to move over my 8 and move over my m and n. So this is going to be 8 equals m plus n. That makes life a little bit easier for us. And let's say I bring the n over, 8 minus n equals m. Once you're there, you can substitute this. So we can substitute this for m over here. So -4, and then m is going to get replaced with 8 minus n plus 2n equals -14. And again, this is just substitution, hopefully shouldn't be mind-blowing stuff. -32 plus 4n plus 2n equals -14. 6n equals, I'm going to skip a step here, bring over the -32 becomes +32, which minus 14 is 18. Divide both sides by 6. N equals 3. Then once you're there, you're just going to substitute that back. Eight minus 3 equals m. 5 equals m. So it wasn't too bad once we had it set up, hopefully. We did have to recall some knowledge from grade 10 academic. Don't forget a therefore statement, therefore m equals 5 and n equals 3. And again, I like that type of question. Example number 5. So the last few examples are going to be a little bit more challenging, or maybe the same difficulty of the ones that we've done, just more steps perhaps. This is a big question. We have yet to do a quintic, a degree of 5. Before you start testing values, if that's what you were thinking to do using the factor theorem, remember the question is just saying factor. So you can use any of your factoring tools in your toolbox. The first thing you should always check for is a common factor. And if I look at all those terms, they all have an x in them. So that means you could actually common factor an x out and make it a little bit smaller of a question. So let's do that. Let's common factor out the x. And when you do that, that decreases each power on x. Now, once we're there, you're going to want to use factor theorem on this. So test plus or minus 1, plus or minus 2, plus or minus 3. You want to test factors of 12. Now I know that f of 3 works. So f of 3 equals 0. Therefore, x minus 3 is a factor. That is my a value. And remember, we only did it on what I underlined. We've already taken out an x. You don't have to worry about doing synthetic division with the longer one, the original one. So we're going to write our coefficients. 2, negative 11, 4, 29, and 12. Bring that down, multiply, add, multiply, add, multiply, add, multiply, add, 0 remainder. We did our work right. However, we've only ever ended up with 3 numbers here. So that's why this is a little bit longer. This is actually 2x cubed minus 5x squared minus 11x minus 4. You're now going to do factor theorem all over again on this. Testing factors of 4. I know f of 4 works. So that's 0, therefore x minus 4 is a factor. We're going to do synthetic all over again with just those coefficients. Multiply, add, multiply, add, multiply, add, 0. We know it works. So I'm just going to continue over here. So that gives us 2x squared plus 3x plus 1. Whew, we're almost there. This also factors. That's not a simple trinomial, but it's a non-simple trinomial because it has a 2 out front. You could use decomposition, you could use box method, whatever you want. 2x plus 1 you should get times x plus 1. So this had multiple, we had multiple things, multiple ways to factor, common factor, box method, and then we had to go through the synthetic process twice. Putting that all together, Therefore, f of x equals x, all of our factors, x minus 3, x minus 4, and then 2x plus 1, and x plus 1. And remember, you should never end up with more factors than your degree. So if by chance you ended up with 6, this has a degree of 5, we've messed up somewhere. Number 6. When f of x equals 2x cubed minus x squared plus kx minus 36 is divided by x minus 3, the remainder is 33. Find k. It might seem kind of intimidating. This really isn't that bad in terms of questions we've done so far. All you have to remember is that that's your a value, 3. So when I put 3 in for everything, or for the x's I should say, we know based off of remainder theorem, it tells us it's 33, so the whole thing equals 33. Using our calculators or our brains, 3 cubed, 27 times 2, 54, minus 9, plus 3k, minus 36, equals 33. Bring over all your numbers to one side, keep your k on the left side. You should end up with 3k equals 24. Divide both sides by 3, k equals 8. Not too bad. All right, we're almost there. And this one's going to be more of a try it yourself question. I'll get you started and then I want you to try it. Kind of think of this as like a pre-test practice. So this function has factors of x minus 1 and x minus 3. Determine a and b. So this is just like the M&N question. Worded a bit differently, and we're going to use things a little bit differently, but more or less almost identical process. So I'm going to get you started. I've told you that it has factors. I've given you 2 of them. So that means that they both, when you put in your a value, you're going to get a remainder of 0. So let's set that up. So the a value here is 1 and the a value here is 3. So when you put 1 in, set it equal to 0. Then do the exact same thing but with 3. So that's as far as I'm going to get you started with. You have the question set up, go through the math, 2 equations, 2 unknowns, just like grade 10 academic. You could do substitution, you could do elimination. It's completely up to you. So I do want you to, even if you haven't been to this point, try this type of question yourself. Think of it as like a practice test question. So hit pause, try it, get a value for A and B, unpause, and get your final answer. Welcome back. Hopefully you didn't break too much of a sweat on this question, and you ended up with, drum roll please, A equals 2. Hopefully we're 1 for 1 so far. And B equals 10. Hopefully you went 2 for 2. If you went 2 for 2, that's awesome. If not, double check, see where you went wrong, maybe ask some questions. So that concludes our marathon lesson. The next two lessons, the last two lessons, are going to be comparatively shorter. There's a bunch of questions to work on, plus a test review. As always, you should only do as many questions as you need to regulate your own learning process. You do not have to do all of them if you know what you're doing. And then do not forget, Wednesday morning, you need to log in the morning to start your test. Wednesday afternoon, we are starting into Unit 3, and then you're going to have your Unit 3 test Friday afternoon, and you'll be 3/7 of the course already done in terms of unit assessments.